Let's take a look at one question from page 58, number 3. It says an elevator moving downward at 4 meters per second experiences an upward acceleration of 2.00 meters per second squared for 1.8 seconds. What's its velocity at the end of the acceleration, and how far has it traveled? So this is a question that's a little bit unlike questions 1 and 2. Questions 1 and 2 involved just gravity. And when it involves just gravity, we know the acceleration will automatically be negative 9.81 meters per second squared. Whether it's moving up or down, it doesn't matter. If it's just gravity acting, A is negative 9.81 meters per second squared. But in this case, it says the elevator is moving downward at 4, but experiences an upward acceleration of 2. We're going to make VI, and be careful here, negative 4. This is the mistake that you guys were making lots yesterday, forgetting the signs. It's moving downward. VI has to be downward, negative 4. But the acceleration is upward, which is positive 2. How can we have an upward acceleration when we have a downward velocity? There's no reason why they have to be the same sign. No reason at all. Okay. The acceleration must be in the same direction as the change in velocity, but not the velocity. If you have a downward velocity, an upward acceleration just means it's slowing down in the downward direction. A positive acceleration means slowing down in the negative direction or speeding up in the positive direction. When I'm moving down and slowing down as I move downwards, that's a positive acceleration. The only time it would be negative is if I was speeding up when I was going downwards. So there's no reason why we can't have a negative VI and a positive A at all. We're going to say delta T is 1.80 seconds. We're looking for VF here, and we're also looking for how far it's traveled, delta D. Now to solve for VF, I think we're going to say A is equal to delta V over delta T, although that's not the only way to do it. And we've been through enough of these now where we're starting to see that there's usually multiple ways. Okay, I do this one way. Maybe you guys do it another way. Works out to be perfectly correct both ways. Whose way is better? If they're both correct, then I wouldn't say anybody's way is better, right? Solving for VF, going to rearrange that first to solve for delta V. A is 2.00, and delta T is 1.80 seconds. So that's going to give me 3.60 meters per second. Now, if I want to solve for VF, I got to remember that delta V is VF minus VI. And then VI is not attached. Take it over to the other side by adding delta V plus VI. I end up getting 3.60 plus VI, which is negative 4.00, gives me negative 0.40 meters per second. So at the end of this acceleration phase, I'm moving at negative 0.4. Should make some sense to us, right? We're traveling at 4 downward, and then we accelerate upward with a positive acceleration. How fast are we moving at the end of it? Well, still downward, but slower because it's an upward acceleration. Make sense? All right, take a look at B here. How far has it traveled here? You got a couple of options here now for sure. D is equal to VI plus VF over 2 times T. D is equal to VIT plus 1/2 AT squared. Probably some other options there as well. I'm going to say VIT plus 1/2 AT squared. VI is negative 4. T is 1.8 plus 1/2 of positive 2 has a time here of 1.8. And we got to square that here. So let's do this on our calculator here. Let's say negative 4 times 1.8 gives me a value of negative 7.2. And now let's add to that, put everything in the second term in brackets here. 0.5 times 2 times 1.8 squared equals negative 3.96, which should it be negative? Of course it should be negative. We're moving downward, right? We start with an initial velocity downward. We end with a final velocity downward. We're moving downward the whole time. My displacement should be a negative value, negative 4 meters or 3.96 meters. Let's take a look at number 2 as well. It says, having scored a touchdown, a football player spikes the ball in the end zone. If the ball was thrown down with an initial velocity of 2, so that would be -2, right? Because it's thrown downward. Negative 2.00 meters per second, or just -2, I should say, meters per second. From a height of 1.75 meters. Well, the height is 1.75 meters, but how far does the ball move? 1.75 meters downward. So we're going to make the displacement 1.75 negative as well. We know that A is -9.81 because the only thing influencing this is gravity. And we're looking for how long it's in the air. We're looking for delta T here. So what are we going to do here? Probably, oh yeah, this is an ugly one. First instinct, probably this one, right? D is equal to VIT plus 1/2 AT squared. But this is the one that we said yesterday. In order to solve for T here, given the other variables, we'd actually need to use the quadratic equation. Remember talking about that yesterday? Now, in the end, we're not going to do that because some of you have never even seen the quadratic equation, and I'm not going to teach it to you here. So what I'm going to suggest you do in number 2 is solve for something else. Get something you're not looking for, like maybe VF, which we can find by using VF squared is equal to VI squared plus 2AD. VF is the square root of VI squared plus 2AD, which, what does that work out to be? Square root of 2 squared, drop the negative because we're talking about speed here, plus 2 times -9.81 times -1.75. Yeah, that's going to give me the speed, which I'll calculate here right now. 2 squared plus bracket, put everything in the second term in brackets here, 2 times -9.81 times -1.75, end the bracket, and then let's square root it by saying second function, square root button, second function answer, gives me 6.1915 meters per second. Okay, so got it? Got the final speed here? That's final speed, right? The final velocity would be -6.9. Want to find the time here? Now it probably makes sense to do, say A is equal to delta V over delta T. And delta T goes up, A goes down. VF minus VI, -6.1915, because it's downward. Subtract -2.0, because it's downward, divided by -9.81. So let's say -6.19, subtract -2, divide that by -9.81, and I get a value here of 0.427 seconds. Does that make sense? How many people got 0.427 for that? Okay, good. Did anybody use the quadratic equation? I know a few people were trying yesterday. Okay, fair enough. Yep. Did you use it? Yeah. What did you get for your 2 values of T? Because you would have got 2 values of T of that.
Yeah, I got 0.835.
So 0.835 and 0.427. What do those 2 different T's mean? Like the 0.835 is incorrect, obviously. So how did you know it was this one? Well, go ahead.
Well, if you graph it, that would be.
Okay, fair enough. No, that's okay. Like the fact that you got it is impressive enough here. Let's say you're throwing the football downwards. If you throw the football downwards, it's going to take 0.427 seconds for the football to reach the ground. If you threw the football upwards at 2 meters per second, it would take 0.835 seconds for the ball to reach the ground. So that's the significance of the other one. Does that make sense? Not that that really matters. Okay, some of you are looking at me like that doesn't make any sense. Well, if you haven't done the quadratic equation, it definitely won't make any sense. Okay, but if you have, then you'll understand why there's 2 answers there, and only one is correct. Okay. Okay, I'd like you to take a look at one question on page 59 right now. Talks about the slingshot dropping riders. But understand here, just so that you understand the context of this question, the slingshot is dropping riders 27 meters. And then it slows them down. So it doesn't stop instantly. Okay, that would hurt. Okay, it slows them down gradually over the green phase here, right? We want to know how fast they're moving before they start slowing down. So we want to find the V right here at the end of the blue section. Does that make sense? VF during the free fall portion of this, not during the ride is stopping portion, but during the free falls portion. Okay? Okay, knowing that, it's probably not going to be too bad of a problem if you understand the context of that problem. Give it a whirl here, and then that's going to be it for us for the day.